Okay, good morning. So we're going to continue with section 12.1. So section 12.1 is about solving system of equations. And in the first video, I teach you how to solve the system of linear equations when we have two equations and two variables. Now we on slide 29 from the PowerPoint, and we will talk about system of equations which have three variables x, y, z. So we'll be talking about how planes are behaving, and to solve the equations like that, we're going to look at point of intersection. Let me just see. Let me go back. I want to make sure I didn't skip anything. Yes, I'm sorry. I have to go back right here. Okay. So we're going to start today solving system of equations containing three variables. So first on the slide, I want to show you what happened when you have three variables, x, y, z. So now we're working with three dimensions, which we don't deal with straight line. To graph three dimensions, we're graphing a plane. And when we're solving system of equations with three variables, which each equation represents the equation of the plane. The system is consistent with one solution, and the solution is right here. It's a point of intersections of those three planes, like you guys see on the slide. So then instead of x and y, you're going to have x, y, z equal, and we graph in three dimensions using three variables. Now, consistent system can be consistent with infinity number of solutions. So this is the example B. So that means that the solution is, we're talking about infinite number of solutions because the solution of that system will be the equation of the plane, the one which is in purple. So every single point on that plane satisfy the system of equations. So that's why we're going to call this system consistent with infinity number of solutions, which means every single point on the purple plane is the solution of that system. And similar like with straight lines, you may have an inconsistent system, which means three planes will never intersect at one point. So this is example C. So they show you the two scenarios of inconsistent system when we're talking about three dimensions. And that system won't have any solutions. You will end up like with something fake, let's say 0 equals 5. So then you will know that you can stop and the system is inconsistent. So we will start. I will teach you how to solve a system of equations with three variables using, and using elimination and substitution method. Okay, so I'm going to the whiteboard and I'm going to solve the first problem. This is a system of equation with three variables. So first of all, it's very important that you guys label each equation correctly. The first one is equation 1, 2, and 3. So you have three variables. So what you want to do, you want to start with elimination method. So first what I want to do, I want to eliminate y. So my plan is to eliminate you know what? Let's do eliminate z, variable z. So what I'm going to do? I'm going to start working with equations 1 and 2. So let me rewrite that system. We have x plus y minus z equal -1. This is equation 1. And 4x minus 3y plus 2z equals 16. This is equation 2. And I want to eliminate z, which means I want to have in equation 1 in front of z -2. So it would be nice if we'll have here in front of z, if we'll have -2z. So in order to get that -2z, we're going to multiply equation 1 by 2. Okay, so that will become, again, everything will multiply by 2. So that will become 2x plus 2y minus 2z equal -2. And this is our equivalent equation 1. And the second equation, just copy without changes. So we'll have 4x minus 3y plus 2z equals 16. And this is equation 2. Now when we have opposite coefficients in front of variable z, we're going to add equations together. And we will end up with 6x minus y equal 14. Okay, so save that. Later, what we're going to do, we're going to replace equation 2 because we add equation 1 and 2. Later, we're going to replace equation 2 with this, 6x minus y equal 14. Okay, now what I'm going to do next, so I will say that's first. Second, work with equations 1 and 3, and also stick to the plan, which means eliminate variable z. Okay, so let me copy equation 1, which is x plus y minus z equal -1. Equation 3, 2x minus 2y minus 3z equal 5. That's equation 3. So the idea is to eliminate variable z. So we have -3z in equation 3. So it will be nice to have in front of z positive 3z from equation 1. So in order to get that positive 3z, we're going to multiply equation 1 by -3. Because -3 times, again, at this moment in front of z, you have -1. So -3 times -1 will give us that positive 3z. So again, multiply by -3z. I'm sorry, just -3. So our equation 1 will become -3x. Every single expression you multiply by -3. So we have -3x minus 3y plus 3z equal 3. And you copy equation 3 without changes, which is 2x minus 2y minus 3z equal 5. So this is equation 1. This is equation 3. And now we're using that elimination method. So we're adding those two equations together. And we end up with -x minus 5y equal 8. Okay, save it. We're going to replace original equation 3 with the yellow equation. Okay, so just to not get confused, like when you guys see, when I use the elimination method, first I work with equation 1 and 2 and I add them together. Since I'm adding second equation to equation 1, that's why equation 2 was replaced with equivalent equation. Now, on the second step, I work with equation 1 and 3. I'm adding equation 3 to equation 1. That's why equation 3 is going to be replaced with the equivalent equation. So now we're going to rewrite the system. So third, rewrite the system using the equivalent equations. Okay, so the first equation stays without changes. I have x plus y minus z equal -1. So we have x plus y minus z equal -1. This is original equation 1. Equation 2 will be the blue equation, which is 6x minus y equal 14. So that's the second equation. And equation 3 will be that yellow equation, which I'll mark in orange. And equation 3 will be -x minus 5y equal 8. So again, that's our new equation 3. And this one here, it's new equation 2. Okay, so now we have equivalent system, but look what happened. Equation 2 and 3 doesn't have variable z. So next what we're going to do, work only with equations 2 and 3, because you already know how to solve the system, which has 2 equations and 2 variables, and solve it for x and y. So let me rewrite equation 2. You have 6x minus y equal 14, -x minus 5y equal 8. So we have equation 2, equation 3. So now it's up to you how you want to solve this system. I'm going to use the elimination method. I'm going to eliminate x. So I will multiply equation 3 by 6 because I really would like to have -6x in front of variable x. So what we're going to do, multiply all by 6. Okay, so we multiply entire equation by 6. So equation 2 will be the same, 6x minus y equal 14. Equation 3 will multiply each by 6, so we have -6x, -30y equal 48. That's equation 3. And now elimination method, which means we're adding those 2 equations together. That cancel, we end up with -31y equal 48 plus 14, which is 62. And we divide both sides by -31. Finally, we have that y is equal -2. When you have 1, this is like almost the end. Now, since we know what is y, I will go back fifth, go back to, and I will pick equation 3. Again, this one, the original one. -x minus 5y equal 8. And substitute y with -2 to solve for x. So we're going to replace y with -2. So we will end up with -x minus 5 times -2 equal 8. We have -x plus 10 equal 8. Subtract 10 from both sides. And we having -x equal -2, which means x equal 2. Perfect. So we already know what is x. We already know what is y. The last what you need to figure out is the variable z. So now what you want to do, you want to go back to equation 1. So sixth step, go back to equation 1 and solve for z. So equation 1 was x plus y minus z equal -1. Okay. And now we're going to substitute. We're going to replace z with 2. We're going to replace y with -2. Okay. So we have x plus -2 minus, I'm sorry, what I'm talking about. Okay, we're replacing x with 2. So we have 2 plus -2 minus z equal -1. This is just 0, so we have -z equal -1, which means z equal 1. So finally we have it. We have x, y, z. So the solution is 3 variables, x, y, z. So that's the point in 3 dimensions, which is 2, -2, z, it's the last one, 1. And like always, you can go back to our original equation, replace x with 2, y with -2, z with 1, and check if you end up with correct solution. Okay, but that's how we're solving system of 3 equations with 3 variables. Takes a little longer, but technically you want to start with the plan, which means you want to eliminate one of the variables. And usually I'm stick to the same rule. I'm working with equation 1 and 2, then 1 and 3. So let's go back to PowerPoint. Okay, what just happened? Let me pause the video and go back to you guys in a second. Okay, so now I'm going back to PowerPoint, slide 29. And here we're going to talk about solving system which is inconsistent, equations which having 3 variables. So here we have the next problem. Okay. So I'm not sure if I have enough space, and I don't want to show you just the solution from PowerPoint because you guys can read that from home. I want to slowly go step by step how to solve this, solve this equation with you guys, and how you're going to know, because this is actually the example of the system which is inconsistent. Okay, so let me go back. So this is inconsistent system. Okay, so here we have 3 variables. We have 2x plus y minus z equal -2, x plus 2y minus z equal -9, and x minus 4y plus z equal 1. So we have three equations, 1, 2, 3, and I want to start with the plan. So I want to start with eliminating one of the variables. And in this case, I want to eliminate x. So my plan is to eliminate variable x. So how am I going to do it? First, I'm going to work with equation 1 and 2. 1 and 2. Okay, so equation 1 is 2x plus y minus z equal negative 2. Equation 2 is x plus 2y minus z equal negative 9. Okay, so the idea is to eliminate variable x. So I really would like to have in front of x from equation 2, negative 2. So in order to do that, I need to multiply entire equation by negative 2. So we multiply equation 2 by negative 2. Okay, the left and right side. So equation 1 stays without change, which is 2x plus y minus z equal negative 2. Equation 2 will be negative 2x, negative 4y plus 2z equal 18. So we have equation 1, equation 2. And now elimination method, so we're adding them together. X's cancel, we end up with negative 3y minus z equals 16. So this equation will replace equation 2. Okay, so this equation will replace equation 2. So this is new equation 2. Okay, so later we'll go back to that. So next what I'm going to do, step 2, work with equations 1 and 3 and the same thing and eliminate x. So 1 and 3. The equation 1 is 2x plus y minus z equal negative 2. Equation 3 is x minus 4y plus z equal 1. So that's equation 1. This is equation 3. We're going to eliminate x. So in order to eliminate x, I would like to have in front of x from equation 3 negative 2. So what we're going to do, we're going to multiply equation 3 by negative 2. Okay, so we're going to multiply entire equation 3 by negative 2. So of course the left side and the right side. So now equation 1, copy without change. 2x plus y minus z equal negative 2. And then equation 3 will become negative 2x plus 8y minus 2z equal 1 times negative 2, which is negative 2. So we have equation 1, this is equation 3. We add them, x cancel, we end up with 7y. What I'm talking about, 9y minus 3z equal negative 4. And this equation will be our new equation 3. So going back to original system, this equation will replace original equation 3. Okay, so this is new equation 3. So now, third, what we're going to do, rewrite the system after elimination of variable x using new equations. Okay, so equation 1, it's the one which we didn't change. So I copy original equation 1, which is 2x plus y minus z equal negative 2. So this is equation 1. Equation 2, it's the one which I mark in yellow, which is negative 3y minus z equals 16. And equation 3, that's the one which I mark in blue. We have 9y minus 3z equal negative 4. This is equation 3. And this is our equivalent system. What you want to do, first you want to work with equation 2 and equation 3 together, because we only have y and z, two variables, and we know how to solve that system, which have two variables. So the fourth step, work with equations 2 and 3 and solve the system for y and z. Okay, so I'll just separate that. Okay, so equation 2, let's copy this down. We have negative 3y minus z equals 16. Equation 3, we have 9y minus 3z equal negative 4. Okay, so it's up to you how you want to solve it. I'm going to use the elimination method. I would like to have in front of z from equation 2 positive 3z. So it will be nice to have positive 3z so I can eliminate z. So in order to get positive 3z, I need to multiply equation 2 by negative 3. So the left side, and of course the right side, we multiply by negative 3. So our equation 2 will become 9y plus 3z equal negative 48. So this is equation 2. And equation 3, we have 9y minus 3z equal negative 4. So this is equation 3. Let's add them together. And that cancel, we end up with 18y equal negative 52. We're going to divide both sides by 18. Now I'm checking if I didn't mess up with anything. Okay, this one, it's good. Okay, so we're getting here that y is equal negative 52 over 18. We can reduce that by Not really. 5218. Let's just leave it like that. So hold on a few seconds. Let me just check. I want to make sure that the work is correct. Okay, guys. So I'm going back to this problem and I find the setting mistake. That's why I stop. So here, the process is correct, but here I messed up with when I was adding equation 1 to equation 2. It was negative z plus 2z. For some reason, I put negative z, but it should be positive z. So new equation 2 was wrong and should have positive z. So let's, I removed the fourth step. I erased that. So we're going to start again. We're going to work with equation 2 and equation 3. And equation 2, it's negative 3y plus z equals 16. Equation 3, it's 9y minus 3z equal negative 4. And now I want to eliminate z, so it's going to be opposite. I really would like to have positive 3z in front of z. So in order to do that, I'm going to multiply equation 2 by 3. Okay, so that will give us negative 9y plus 3z equal 48. That's equation 2. And equation 3, it's 9y minus 3z equal negative 4. And elimination method, we adding those two equations together, cancel, cancel. So we end up with 0 equal 48 minus 4, which is 44. And like you guys see, this is fake. This is wrong. So we're going to stop here. And this system has no solution. So no solution means the system is inconsistent. Okay, so that was example 2 from PowerPoint, and we have one more to solve it. So we'll just go back. And I want to show you how to express the solution of system of dependent equation containing 3 variables. So that's the example when the system has infinitely many solutions. In this case, we're dealing with 3 dimensions, so infinitely many solutions will be the entire plane. So every single point on the plane, which has 3 dimensions, x, y, z, will be the solution. So here we'll work with example 3 from PowerPoint. Let me copy this example on whiteboard. So system with dependent equations. So example 3. So this one is solving system with dependent equations. Okay, so the first equation is x minus 2y minus z equal 8. 2x minus 3y plus z equal 23. That's equation 2. 4x minus 5y plus 5z equal 53. Equation 3. So the same idea, I'm going to work with equation 1 and 2 and then 1 and 3. And usually I'm stick to that because I'm trying to be organized and then not mixing different equations. So I have to come up with the plan. So the plan is to eliminate, and I want to eliminate z, variable z. So first I'm going to work with equation 1 and 2. And look what happened. Hopefully you guys don't mind, but since I already have opposite coefficients in front of z, I'm just going to quickly add them together. Equations 1 and 2. Okay, let's add them together. So we have x plus 2x, which will give you 3x, negative 2y minus plus negative 3y, that is negative 5y, z cancel, and we have 23 plus 8, which will be 31. So this is new equation 2. Okay. Okay. So that will replace the equation 2 later. Now next, work with equations 1 and 3. So we have equation 1, it's x minus 2y minus z equal 8, 4x minus 5y plus 5z equal 53. So equation 1, this is equation 3. The same idea, we want to eliminate z. So in order to eliminate z, it will be nice to have, here right now we have negative z, negative 5z. So in order to do that, I'm going to multiply equation 1 by 5. So multiply entire equation 1 by 5. Okay, so we'll end up with 5x minus 10y minus 5z equal 40. So this is equation 1. Equation 3, 4x minus 5y plus 5z equal 53. In elimination method, let's add them together, and that will give us 9x minus 15y, z cancel, and we have here 40 plus 53, this is 93. Okay, and this is equation 3, new equation 3. Okay, so now I'm going back and I'm going to rewrite the system using new equations. New equations. So we have x minus 2y minus z equal 8, equation 1. Then we have 3x minus 5y equal 31. This is equation 2. And equation 3, we have 9x minus 15y equal 93. This is equation 3. And now what we're going to do, we're going to work with equation 2 and 3 to solve for x and y. So we're working with equation, again, 2 and 3 because we want to solve for x and y. Use equations 2 and 3 to solve for x and y. Of course, if it's possible. So we have 3x Let's copy them down. 3x minus 5y equal 31. Equation 2. 9x minus 15y equal 93. This is equation 3. I like to use elimination method also here. So I'm going to multiply equation 1 by negative 3. So in front of x, I can have negative 9x. And I can eliminate x. So we multiply equation 2 by negative 3. So that will give us negative 9x plus 15y equal 3 times 31, which is 93, negative 93. And so this is equation 2. Equation 1, we have 9x minus 15y equal 93. Equation 3. Elimination method, add them together, x cancel, y cancel, and we end up with 0 equals 0. Okay, so this is true. When you end up with something like that, that means the system has infinitely many solutions. Infinitely many solutions. So we still want you to express the solutions and using equations. So this is not the end. Going back to this problem, my plan was to eliminate variable z. So since I know that my system has infinitely many solutions, what I'm going to do, I'm going to assume, we're just going to say that z is any real number. And now our job is we need to express x and y using variable z. So technically what we're going to do, we're going to treat that z like a constant. Okay, so I'm going back to this equivalent system. So which one? Right here. I'm going back here. Okay, so we know already the system has infinitely many solutions. However, we need to express the solution using variable z. So what I'm going to do, okay, I'm going to work with equation 2. So equation 2 was in orange. I'm going back to equation 2, new equation 2, okay, which is 3x minus 5y equal 31. And I'm going to solve this equation for x. So 3x is equal 5y plus 31. X is equal 5 over 3y plus 31 over 3. Okay? So I'm going to use substitution method. So now I will go back to equation 1. So again, equation 1 was, make that a little smaller, but I can't. X minus 2y minus z equal 8. So I went back to equation 1 and I'm going to replace x excuse me. And we're going to replace x with 5 over 3y plus 31 over 3. Okay, so we have x, which is we're going to replace with 5 over 3y plus 31 over 3 minus 2y minus z equal 8. So I'm just going back and I'm going to actually not z, but I'm going to assume that y is any real number and we need to express x and z using variable y. You guys will see that in a second, using variable y. Okay. So equation 1. Like you see, guys, look what happened. Let's simplify that. So we have 5 over 3y minus 2y. 2y is the same as 6 over 3. So I just rewrite 5 over 3y minus 6 over 3y plus 31 over 3 minus z equal 8. So from here we're getting negative 1 over 3y minus z equal 8 minus 31 over 3. So we have what's going to happen. Look what I did before. I express x using variable y, not like originally I told you z. It ended up to be using equation variable y. And I will do the same thing. I will solve this equation, which I have it here, solve for z. So we'll end up with, I will add 1 over 3y to both sides. So we end up with negative z equal 8 minus 31 over 3. So 8 is the same as 24 over 3 minus 31 over 3 plus 1 over 3y. So negative z is equal. We have 24, 6, 7. So we have negative 7 over 3 plus 1 over 3y, and just divide each by negative 1. So we have that z it's equal negative 1 over 3y plus 7 over 3. So this is our solution, okay? So the solution, this system still has infinitely many solutions, but you want to express the remaining two variables using one of the variable. In my case, it's ended up to be y. So the solution is, I can just write down that way. The solution is x, y, z, such that x it's equal 5 over 3y plus 31 over 3. Okay. Z it's equal negative 1 over 3y plus 7 over 3, and y is any real number. So why we do that, I'm quickly going to show you, because when system has infinitely many solutions, so again, you have infinitely many points on the plane which represents that system. So here when I mentioned that y is any real number, and again, you could do that z is any real number and express x and y using z. I just didn't want to change what I started working on it. So let's say if y equals 0. Okay, so look what happened. X is equal 5 over 3, replace y with 0, plus 31 over 3, and we're getting 31 over 3. and z will be equal -1/3 times 0 plus 7/3. So z will be equal 7/3. So one of the solution will be x, y, z, which x will be 31/3. Z is equals y equals 0, z is equals 7/3. So when the system has infinitely many solutions, you just treat one of the variable like a constant. And you can find, let's say, 5 more points doing the same way. You can make y equal 1 and calculate what is x and z equal. Okay, so this system is consistent and has dependent equations. So this is the example how you can find points of system with infinitely many solutions. Okay, so I will go back to PowerPoint. Here on PowerPoint, you have the same problem, solve it and explain it. Also, the solution continue, and the PowerPoint actually express the solution using variable z. So they make z equal any real number, and they express x and y using variable z. And you guys can go ahead and check. You will end up with exactly the same points, infinitely many points. But it shows you how you can express x and y using variable z if you would like to compare. Okay. And that's it of the section 12.1. So I make on Canvas this PowerPoint available for you, which has explanation of all the problems which I went over. Also, I will attach with video 2 the notes where I show you how to solve the 3 examples of system with 3 variables. Okay, so I wish you the best, and I will talk to you soon.